All right, today we are going over 5.2 nomenclature for ionic compounds. And again, nomenclature just means naming. How do we name something? And so we've done this for covalent bonds. Remember, with covalent bonds, we used prefixes. Um, for ionic bonds, we don't need prefixes, and that's because of how the charges work. And I'll show you how that works here. So before we begin, we have to talk about something we touched on before, and that is these things right here. They're called polyatomic ions. And at first, polyatomic ions look quite complicated, but they're actually really simple, and we're going to treat them very simply as well. Just make sure you follow the rules we lay out, and it'll make sense. So to start here, we are going to bring up kind of a double worksheet day. Sorry, but it's really good practice. Okay, let's bring this up. So I hope you start this one off, and then once you get the hang of it, it's you can do it pretty easily on your own. What we're going to need is we're going to need the back of our periodic table. If you flip your periodic table over, you will have this right here. Now, if you're at home doing this on your own, maybe right now would be a good time to take a picture of these right here, our polyatomic ions on this side. It's also really easy to Google them. You can look them all up, right? All right, so this is how this works. So I'm going to count up the atoms and write the formula, and then I'm going to find out what polyatomic ion is that. Let's look at this one right here. I'm going to first look at the central atom, right? Central atoms. And I'm going to say, okay, right there I've got Cr. How many Crs do I have? Just one. And then I have O. CrO. I got 1, 2, 3, 4 oxygens. So I'm going to put CrO4. Now up here, super important because they're called ions because they have charge. So I need to put the charge. So it is CrO4 minus 2 or negative 2 charge. So what is the name of this polyatomic ion? Let's look over here. So they're all in alphabetical order. And if I look for CrO4 minus 2, I'm going to find it right here. This is called chromate. That's what I'm going to write over here, chromate. And that's it for that one. Let's move on. And so what is this exactly? What does this mean? Well, it can be quite complicated, I already said. But all we're saying is that these things have bonded together and they have a negative charge. Most of them have a negative charge. If you look here, there's one that has a positive charge. It's this one right here, ammonium, NH4 plus. It's the only one that has a positive charge. All the other ones are negative, and they're almost exclusively made out of all non-metals. There are some exceptions like permanganate, and we're going to treat them like non-metals, and that's it. We're just going to treat them like non-metals. To make it easier, we will put them in parentheses, and you'll see how that works in just a second. So what did we learn about non-metals before? Non-metals are going to gain electrons and become negative, and that's it. So let's try another one. Let's try one that's maybe a little more difficult. All right, I want us to be a little careful here. Look at this one. It has 3 oxygens. This one has 2 oxygens. Their names are very similar, but it's not the same name, so be careful. You know, let's try this one here. This one's a little more difficult. My formula is, okay, I got carbon here in the middle. I'm going to put carbon. How many do I have? 1, 2. 2 carbons. Now, I don't care if you put the H first, if you put the O first. But we're going to put the H first because it comes first. 1, 2, 3 H's. 1, 2 oxygen. Has a charge of minus 1. Alright, so I'm going to try to find this on my periodic table. My polyatomic ions list. And here it is. It's the first one. C2H3O2 minus. Now if it says minus, that means minus 1. And that is called acetate. Acetate. Oops. That's what I'm going to write in here. Acetate, like acetic acid. And that's how you do the top part. Make sure you get them all done. And I'm going to show you how to do the rest. All right, on this one, this is similar to how we've done every bonding thing in the past. So let's find the first one is magnesium acetate. Let's find, see, I think I got it here. So magnesium is going to make a +2 charge because it's in the second column. I've got Mg right there, so I'm going to write that in. It's +2. And we know that acetate we just saw was C2H3O2 -1, right? So how do we bond these two things together? Well, we're going to do the same thing as we did before. We're going to look at their charges and say, do their charges match? No, they don't. And we need to do crisscross applesauce. But before we do that, we have to put this in a parentheses. We treat this as if it's one thing, and everything here stays the same. We do not change these numbers. So, crisscross applesauce, I'm going to take this one, drop it and cross it over. It goes outside of my parentheses. And I'm going to take this, remember, just the number. I'm going to take just this number here, drop it and cross it. It goes down there. So I'm going to end up with Mg1, so I don't have to put the 1, C2H3O2, 2 on the outside. Let's look at the next one. Let's go with, okay, rubidium sulfite. All right. Here's rubidium. Rubidium is going to have a +1 charge. Let's write that in. We got R. Oops. Rubidium is +1. And then what is sulfite? I'm not sure, but I do know that my polyatomic ions list is in alphabetical order. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S. There it is. Now be careful. That says sulfite. Here's sulfite. Oops. Got so many periodic tables here. Here's sulfite, not sulfate. So this one is SO3 -2. Let's put that in there. Okay, now we treat this the same as anything else. Do their charges match? No, they don't. Then we're going to do crisscross applesauce. Just in case, I'm going to put this in parentheses. I'm going to take this number. I'm going to put it down there. I'm going to take this number, and I'm going to put it down there. I'm going to end up with RB2 SO3. Now, in this instance, I don't necessarily need a parentheses, but I can leave it there, and it's just fine. It makes no difference because there's no number out here. It doesn't matter. I also want us to notice two things. One, the charges went away. The charges are gone. Number two, I only move the numbers. Please, only move the numbers because they cancel out. The charges cancel out. +1 -1, +1 -1. They cancel out to 0, so we don't need them anymore. I think you can figure out these two on your own. Again, don't forget ammonium is a polyatomic ion. Now the bottom part of this, the other part, the other side of this is actually really straightforward. So something we're going to learn about in class, if you're in class, is that ionic compounds, and we can write this here, ionic compounds conduct electricity. In water. Now, like salt, if I just have table salt there, it doesn't conduct electricity. But if I put the table salt into water, then the water will conduct electricity. And we're going to learn more about that later when we talk about solubility in a whole other unit. But for now, all we need to know is that if it's ionic, it conducts electricity in water. So we just have to determine, are these things ionic or covalent? And we said if it has a metal, it's ionic, and that's really all we have to find. Now we can make it a little more complicated. We can say, oh yeah, covalent bonds are all nonmetals and ionic bonds are metals and nonmetals. But when it really comes down to it, if the first thing you see is a metal, it's ionic. If it's not, it's covalent. So let's check the first couple that we have here. Let me pull out my periodic table. NH3. I'm going to look over here and I'm going to find nitrogen. Now again, nitrogen is on the right side of this line right here. Everything on this side is a non-metal, and everything on this side is a metal. So nitrogen is a non-metal. So that means this is not ionic. Let's look at the next one, calcium. Calcium's right here. Calcium's way over here. Calcium is a metal. This is ionic. This one's covalent. This one's ionic. Let's look at this one, Mg. Magnesium is right here. Magnesium's definitely a metal. This is ionic. I don't have to look at anything else. I just need to see, is the first thing a metal? If it is, it's ionic. Let me clear all this up for us real quick. So what does this mean to us? Okay, if it's covalent, it does not conduct electricity. If it's ionic, it does conduct electricity. Ionic? Yes. Essentially what we're asking ourselves here is, does it have a metal in it or not? Yes or no? And that's how simple that is. Okay, let's get back to our notes. Okay, so now that we have a decent understanding of what a polyatomic ion is, again, don't look too far into it. We're just going to treat them as if they're non-metals. Except for ammonium, that's the only exception. Let's look at how we name these things. First, we need to know if it's ionic or covalent. And we just talked about how can we tell if something's ionic or covalent, right? So we look at the first element. Let me pull up my periodic table here. And at this point, we really should be kind of memorizing where some of these things are. Like sodium. We talk about sodium every single day in this classroom. We talk about water every day. We talk about magnesium almost every day. All right, so sodium we should know is over here. Sodium's an alkali metal. That's right, a metal. So this is ionic. It has to be. It has metal in it. Water is our number one most easiest known covalent molecule because it has no metals in it. Hydrogen is a non-metal for sure, and oxygen is a gas. We know this. CH4, this one actually a little bit more difficult. I got carbon right here and hydrogen. Now I know that hydrogen is a non-metal. That one's the obvious for me. But what about carbon? If you think about what carbon is, like charcoal, right? Is that a metal or a non-metal? How does that count? Well, it's easy. If it's on the right side of this, it's a non-metal. So carbon's a non-metal. This is covalent. And then we got calcium, CO3. Oh, this right here, that's a polyatomic ion. That's called carbonate. But we treat carbonate as a non-metal. So this is simply to us a metal, calcium, because we should know calcium's right there. And a non-metal. A metal and a non-metal together, that's an ionic compound. Okay, here we're trying to test, can we tell if this is ionic, covalent? And if it is ionic, does it have a polyatomic ion in there? So let's pull this out over here and we can check on our, I guess that's a little more difficult. Let me see if I can move that over for us. Kind of funny to have my wife as a background. It's kind of a joke to me. It's cute. All right. If we can figure this out. Okay, that's good enough right there. So that's what this means right here. Binary or polyatomic. Binary just means two things. So if you only have two things, that's a binary compound. If you have multiple things, then that's polyatomic. Poly meaning many. So this first one, we have magnesium and nitrogen. First, magnesium is a metal. Magnesium is a metal. That means it's ionic. So is it binary or is it polyatomic? That's what we have to figure out. Well, we have Mg and N. Now I know you have 3 Mg's and 2 N's, but we only have one type of metal and one type of nonmetal. That's two things together. That makes it binary. Binary means two things together. All right, this next one, NH3. This is called ammonia, not ammonium, ammonia. So N is right here. H is right here. We know H is a nonmetal. We know N is a nonmetal. Two nonmetals together, that's covalent. All right, we already talked about it a couple of times. Calcium is a metal. It's right there. Sorry, that was real ugly. Calcium is a metal. It's right there. So is it binary or polyatomic? Well, I have calcium and oxygen and hydrogen. So that's two things right there. That's actually called hydroxide. This is a polyatomic ion and a metal, so this is polyatomic ionic compound. Carbon and oxygen. I know for sure oxygen is a nonmetal. And we just talked about how carbon is a nonmetal. Two nonmetals makes it covalent. All right, again, calcium right here. We know calcium's a metal, so it's ionic. Is it binary or is it polyatomic? Well, I've got calcium and carbon and oxygen. So I've got more than two things. That makes this polyatomic. That's actually called carbonate, CO3, carbonate, a very common polyatomic ion. So we run into a weird transition here. Me and one of the other teachers have decided we're going to save this for Friday. So we're going to skip ahead from this page to this page right here. We get to naming. So how do we name these things? Well, once we figured out, is it a binary? Is it a polyatomic? Does it have transition metals or no transition metals? Then we can figure out how to name certain things. Now, the part that we're skipping for now is the transition metal part. So we won't do that today. We'll do that next time. So again, we're on page number 11. And it's pretty straightforward. We just got to figure out what our positive ion is, what our negative ion is, and then we name it with "ide." So here's our positive ion on this one is sodium. Guess what? It's always going to be the first thing, and it's almost always going to be a metal. There's only one exception to that rule. So Na is sodium. S is sulfur. This is a binary compound, cation, anion. And so I'm just going to name this sodium sulfide. We drop the ending and add IDE. We should know all the ides at this point. If not, they'll be written on the board for you when we take our test. Okay, so let's decide magnesium and chlorine. Let's pull this down a little bit to it. All right, so our cation will always be our metal. Magnesium is our metal here. So this is a main group metal because it's not a transition metal. So magnesium. Okay, and then what's the second part? Cl. That's really simple. There's no polyatomic to it. It's just a single element. And we've seen this a bunch of times. This is chlorine. And so all we're going to name this is magnesium chloride. That's it. We don't need any prefixes, anything like that. Magnesium chloride. Man, that looks ugly. Sometimes it's hard to write on this thing. I guess I'll write off the page. Who cares? All right, this one, Al, is right here. That's aluminum for us. That's aluminium. And then O, we should all know what O is. Oxygen right there for us. That is binary because it's not polyatomic. And this is just going to be called aluminum oxide, as you might have guessed. Aluminum oxide. Okay, now we're getting to some that are a little more tricky. Let's look at this next one. So, let me get rid of all this. So, the first one is Li. Li is lithium. That's straightforward. It's just a regular metal. It's just a main group metal, lithium. But OH, there's no OH here on our periodic table. That's because it is a polyatomic ion. Let's look at our polyatomic ion list. You can see right here, OH, that's that one, OH. OH is called hydroxide. So we're going to write that as our polyatomic negative ion is hydroxide. Now when it comes to naming something with a polyatomic, all we have to do is rewrite it. It makes it even easier. We don't have to add I to it. We just write whatever the polyatomic is. So the name of this one is going to be called lithium hydroxide. No change. Cool. All right, this one. Calcium. Want we go this way? No. Calcium, we should know now. Calcium is a metal. Here it is. Right, calcium. And then Cl, we've seen it so many times. It's chlorine. How are we going to name this? Calcium chloride. All right, so this is getting really ugly here, so I'm going to delete all this. If you need to write this down, pause it for a second. Okay, let's move on. So here, again, I've got Li. I know I've already seen that's lithium, and it's a main group metal. But then here I have NO. Remember, if there's multiple capital letters, that's multiple elements. So I know for sure that is a polyatomic ion. So I have to go find it. I have to be sure to get the right one, because that says NO3. Let's look. I've got NO2 right here and NO3 right there. So it's this one. This is the one that they're asking us for. This is called nitrate. So that's what I'm going to put. For my polyatomic, because it's a polyatomic ion, I'm going to put nitrate. Just like we saw. And we said, when it's a polyatomic, we just name it lithium nitrate. There's nothing special about it. All right, let's look at these last two. All right, BA. Let's find BA. Ba is way down here. It's in the second column. It's an alkaline earth metal. No, it's a main group metal. And that's called barium. And then it's in parentheses. It couldn't be more obvious. This is a polyatomic ion. Let's look at a polyatomic ion list one more time. ClO3. Oops, gotta move this one up. Ooh, I don't see it. Ah, here it is. CO3, ClO3. There it is. ClO3. This is called chlorate. Let's write that down. Again, this is going to be called barium chlorate. Next one, NH4. That one's special. And anytime you see NH4, you should just know that's a polyatomic ion. You have to come back here and look. This is the only polyatomic ion that acts like a metal. It's the only one that's positive. And this is called ammonium. It's got an M at the end. Don't forget it. Ammonium. This is ammonium. And then my anion is S. And we've seen S before. S is sulfur. We should know sulfur is a nonmetal. So this is ammonium sulfur. We change the ending to IDE. This is going to be called ammonium sulfide. So that's the easy part. I said that naming here was going to be different than naming covalent, because once you figured out what the elements are, you just put IDE at the end. Sodium and sulfur, sodium sulfide. No prefixes. We don't worry about how many we have or nothing. This part is a little bit more difficult than that, but only because we need to know the charge. So here we have to utilize our charge. As you can see, all I'm going to do is I'm going to take what it says. So this is sodium. I know this sodium is Na. I know it has a charge of +1. And then I have to figure out what is sulfide. Well, we remember that it's just sulfur, right? We just change the ending to IDE. So we find sulfur. We see that it's -2. And then we do crisscross applesauce if we need to, Na2S. Let's look at the next one, sodium nitrate. So we know first off, sodium doesn't change. Anyway, sodium is Na+. And again, we talk about sodium every day. We should know this one. But nitrate, it's got an 8 ending, not an ide. So we know for sure this is a polyatomic ion. So let's look for it. All right, nitrate is NO3, and then it has a minus there. Now, a lot of people get confused and think that's saying -3. It's not. It's saying NO3, and then minus meaning -1 charge. When we don't have to write 1 in chemistry, we just don't. So nitrate is NO3 -1. Sodium is +1. Okay, then we have to ask ourselves, do these numbers match? Yes, they do. Then all we have to do is rewrite these things without any charge. NaNO3. We could put this in parentheses if we want to, but we don't have to, because there's only one of each. That's it. All right. Ammonium nitride. Let's look on our polyatomic ions list. We've said ammonium a bunch already. It's the special one. It's the only one that's positive. NH4+. Let's put that one in here. So NH4. And plus means +1. And then nitride. I know there's nitrate and nitrite and all these other nitros in there, but nitride's the original one. Nitride is just nitrogen. Nitrogen's right there, and if you look on your periodic table, you'll see that nitrogen has a charge of -3. So let's use that. So nitrogen has a charge of -3. Do these numbers match? No, they don't. So I have to do crisscross applesauce. I'm going to be very careful. I'm going to put this one in parentheses just in case. I'm going to take this number, not the charge, and I'm going to put it down here. And I'm going to take this number and I'm going to put it down here. I'm going to end up with NH4. Remember that 3 went down here, so 3 goes on the outside. And then N1, and I don't have to write the 1. All right, calcium oxide. Let's look this up on our periodic table real quick. Calcium's right here. Calcium is going to have a +2 charge. Oxide, if we remember, hopefully, that's oxygen. And oxygen has a -2 charge, so +2 -2. Do these numbers match? Now, this is the one that most people will get wrong because it's 2, but the numbers match. That's the question. Not, are they both 1? No. Does this number match this number? Yes, it does. Then all I have to do is rewrite these without the charge. CaO. That's it. That's one of the most confusing ones I see most people get wrong the most times. If these numbers match, they just disappear. And we just write CaO. Nothing more. Next one, lithium. We've seen lithium a bunch already today. I'll show you just one more time. That lithium is a +1 ion because it's an alkali metal. Lithium's right there. It's +1. But it says lithium carbonate. Now, that's not carbon. That's not carbide. That's not anything else. It's a carbonate, so we know that that weird name must mean it's a polyatomic ion. So let's find it in our list. Remember, these are in alphabetical order, but this is easy to find right there, carbonate. So this is CO3, and this one actually has a charge of -2. So CO3 -2. Again, does this number match this number? No, it does not. Crisscross applesauce. I'm going to put this in parentheses just in case. This number goes outside of my parentheses. This number goes down here. The charges go away. So I have Li, that 2 went down there. And then I see that I'm just going to have one CO3, so I don't have to put it in parentheses. I can, but I don't have to. Okay, last one, calcium phosphate. We've already done calcium multiple times, so I'm not going to look it up for us again. Calcium is +2, and it doesn't change. Phosphate, though, that's definitely a polyatomic ion. It doesn't say "ide," so it's an 8. So it's in alphabetical order. Here it is. Phosphate is PO4 -3. That's P4 -3. Do these numbers match? 2 and 3? No, they do not. Then we're going to do crisscross applesauce. I'm going to put this in parentheses just in case. This 2 goes outside of that number, outside of that parentheses. This 3 goes down here. So we're going to get Ca3, right? And then we will keep this one in parentheses this time because it has a number outside of it. 2, right? Anytime I'm moving a number besides 1 to a polyatomic, it's got to go outside of the parentheses right there, just like that, just like we did with this one as well, okay? So next time we will talk about transition metals, how to name transition metals. It's pretty straightforward, and that's it for today.